across the equatorial Pacific.
One of the key elements of what we call the ENSO observing system is this network, 70 deep ocean moored buoys that spans the width of the tropical Pacific from near the coast of South America to near the coast of New Guinea. Each one of these buoys is anchored to the ocean floor with old railroad car wheels. There's about 3 or 4 miles of nylon and steel rope. And on this rope, in the upper third of a mile or so, we have 10 temperature sensors. And then at the surface, we have a little donut-shaped float that has on it a tower with instruments to measure air temperature, winds, and some other atmospheric variables. These buoys return data from the tropical Pacific about 6 times per day. So we can essentially track the evolution of the climate system in this part of the world on an hour-by-hour, day-by-day basis.
The data beamed to McFadden and his team in Seattle is routed immediately to the World Wide Web and a worldwide audience of researchers. Available too is data collected by satellite, remote sensing platforms which monitor every aspect of tropical atmosphere and ocean. Researchers look for abnormal wind patterns and for changes in sea surface temperature, signs of a new El Nino up to 6 months ahead of destructive side effects.
If you can observe the evolution of the climate system in the tropical Pacific with the kind of clarity and precision that we can with this buoy array and with also other kinds of climate measurement techniques that we have today, once you see unusual temperatures develop, we know historically that they will persist for 3 to 6 months into the future.
Because El Nino develops slowly, observation is the best way to forecast in the midterm. But for long-term forecasts, for warnings years in advance of El Ninos, other tools are needed. Many researchers are putting their faith in climate models, in cyber oceans and cyber atmospheres. El Nino after El Nino, born, living, dying in the minds of supercomputers. The models are fed real-world data from the array of buoys and from Earth-observing satellites. The supercomputers run this data into the future, calculating climate months, even years in advance, based on scientists' assumptions about how El Nino works. Those assumptions and the systems keeping watch on the real world were tested severely, much sooner than the science community expected. Researchers had dubbed the 82-83 event the El Nino of the century, in the belief that another super El Nino was decades away. Once again, science got it wrong, because the event of 1997-98 was even more powerful. What science got right was El Nino surveillance.
We were much better off in 97-98 with regard to preparedness because we were able to observe the 97-98 El Nino, and we were able to track the El Nino as it evolved essentially day by day. This meant that individuals, companies, governments, both state governments and national governments, could take action that would mitigate against some of the more adverse aspects. For example, in Southern California, coastal communities were mobilized to build beach berms, protecting against the high waves that they expected from storminess. This kind of preparedness was undertaken on a scale never before possible because we didn't have the lead time information that we had before 97-98.
Success for the watchers, but according to Mickey Glantz, failure for the cyber forecasters.
The monitoring of El Nino has greatly improved since 1982-83. I would argue also that the forecasting of El Nino has not greatly improved. 15 major forecasting activities for the 1997-98 event failed to forecast the onset of that El Nino. My personal feeling is that every El Nino has surprised us. The mystery of El Nino is bigger than we thought.
One mystery of El Nino was solved only recently: the phenomenon's age. And once again, El Nino surprised us. The answer was drawn from ice, wood, and mud. Ice cores from glaciers, which hold and preserve the chemistry of ancient atmospheres. The annual growth rings of trees, clues to rainfall and temperature changes over hundreds, even thousands of years. And sediments from the beds of Peruvian lakes, in which are recorded the furies of El Nino storms. From these, we have learned that the Christmas child, which came to the attention of science only a century ago, has been causing chaos for more than 15,000 years. Most scientists had thought it a more recent climate event. Building on the breakthroughs of Earth science, archaeologists are revisiting the mysteries of peoples like the Moche. It's thought that the ultimate power wielded by the Moche elite, society's living gods, came at a price: ultimate responsibility. It was the job of the human deities, the warrior priests, to regulate the forces of nature.
When you assume the functions of a deity, you have to provide what the deities are supposed to provide, and that is the welfare of society. I mean, you are responsible for everything good, but you're also responsible for everything bad.
It's now clear that for the Moche, nature's most dangerous tantrum was El Nino.